Welcome to today's lesson, the unit circle. A unit circle is a circle with a radius of 1 unit. So I'm going to draw one. It's a circle that's centered at the origin. It has a radius that is 1 unit long. The radius forms the terminal side for a theta that's in standard position. I can identify this point where the radius touches the circle as some ordered pair x, y. I can drop a vertical line down to the x-axis and make a right triangle. The horizontal leg of this triangle has to be x units long. The vertical leg has to be y units long. So if we use SOHCAHTOA, we can see something interesting. We can say that the sine of theta opposite over hypotenuse has to be y over 1, which means that y is equal to the sine of theta. Cosine of theta, adjacent over hypotenuse, is x over 1, which means that x has to equal the cosine of theta. And then tangent of theta, opposite over adjacent, is y over x. Well, if y is sine of theta and x is cosine of theta, this means that the tangent of theta is equal to the sine of theta over the cosine of theta. So now that we've said what x and y are equal to, we can rewrite this ordered pair as the cosine of theta and the sine of theta. So before we start tackling the entire unit circle, it's helpful to look at quadrant 1 because quadrant 1 really has all the information that we need. So you can see that we've identified some special angles. Their terminal side are those red radii. And those angles are 30 degrees, 45 degrees, and 60 degrees. And so I've just pulled those triangles out to the right so we can see them more clearly. So let's start with the 30-degree angle in standard position. This is going to correlate to this triangle right here. So we know that the horizontal leg has to be the square root of 3 over 2, which means the x-coordinate is the square root of 3 over 2. We know that the vertical leg is 1/2 units long, so that means that the y-coordinate has to be 1/2 unit long. So we'll try the same thing with our 45-degree triangle. And both the horizontal and vertical legs are root 2 over 2, which means that the cosine and sine of 45 degrees have to be root 2 over 2. And then we'll look at the 60-degree angle. And when we look at that triangle, we know that the horizontal leg is 1/2, which means that the x-coordinate has to be 1/2, and the vertical leg is root 3 over 2, which means the y-coordinate has to be the square root of 3 over 2. So to complete the unit circle, or quadrant 1 of the unit circle, we also just have to consider the two quadrantal angles. We have 0 degrees, which has the ordered pair 1, 0, and we have 90 degrees that has the ordered pair 0, 1. Before we continue filling out the other quadrants of the unit circle, we need to talk about the idea of the reference angle. And this is an acute angle formed with the terminal side and the x-axis. So let's just work quadrant through quadrant. Let's talk about an angle in quadrant 1. I'm going to use 45 degrees. Well, 45 degrees is an acute angle, an angle that measures 90 degrees. So for theta equals 45 degrees, its reference angle theta prime is also 45 degrees because that is the angle formed by the terminal side and the x-axis. In quadrant 2, I'm going to deliberately pick an angle that has a 45-degree reference angle, and I'm going to draw 135 degrees. This angle over here, made with the x-axis, is 45 degrees. So if theta is 135, its reference angle is 45 degrees. Again, I'm going to deliberately pick an angle now in quadrant 3 that has a 45-degree reference angle. So I'm going to draw 225 degrees. But the angle made between the terminal side and the x-axis is like 225 minus 180, which is 45 degrees. So this means that if theta is 225, its reference angle is still 45. And then finally in quadrant 4, if my theta is 315 degrees, 360 minus 315 gives me a reference angle that's equal to 45 degrees. So theta is 315 and its reference angle is 45 degrees. So now we're going to look at the entire unit circle. I went ahead and copied the information from quadrant 1 from the last page onto our blank unit circle. So I think the next thing we should try to do is to fill in all the angles. And I'm going to start by just doing this in degrees. Let's look at our quadrantal angles. We know halfway around the circle is 180 degrees. We'll go down to the negative y-axis and we'll put 270 degrees, and then we'll go all the way around. We have done one rotation, which is 360 degrees, which shows that 0 and 360 are coterminal angles. So now let's look at the angles in quadrant 2. We can see that this angle and this angle share the same reference angle. So if this angle is 30 degrees, then this angle has to be 180 minus 30, or 150 degrees. This angle is 45 degrees, which means this angle has the same reference angle. So 180 minus 45 is 135. And finally, this 60-degree angle has to be the reference angle for this angle here, and 180 minus 60 is 120 degrees. So now, using the same idea, here we have a 30-degree reference angle. 180 plus 30 is 210. This angle right here has a 45-degree reference angle, so this has to be 180 plus 45, or 225. And this one has a 60-degree reference angle, and 180 plus 60 is 240. And then finally, in quadrant 4, the small angle here has a 30-degree reference angle. So 360 minus 30 is 330 degrees. If this has got 45 degrees, then 360 minus 45 is 315. And then the big angle has a 60-degree reference angle, and 360 minus 60 makes this 300. So now we have all of our angles filled in degrees, but our unit circle isn't complete unless we do everything in radians as well. So knowing that 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, and 90 is pi over 2, we should be able to figure out the rest of our angles. Let's do our quadrantal angles again. 180, or halfway around, half of 2 pi is pi, and then 3/4 of the way around is 3 pi over 2, and then finally one full rotation is 2 pi. Now it's interesting to think about pi. Pi is the same as 6 pi over 6, 4 pi over 4, and 3 pi over 3. So if I want to use my reference angles to calculate my angles, instead of converting using pi over 180, I can just say then that pi, or 6 pi over 6, minus pi over 6 makes this one 5 pi over 6. My 135-degree angle is going to be 4 pi over 4 minus pi over 4, which is 3 pi over 4. And my 120 angle is going to be 3 pi over 3 minus pi over 3, or 2 pi over 3. Now we'll do the same thing by adding those angles to pi in quadrant 3. So 6 pi over 6 plus pi over 6 makes this 7 pi over 6. Pi, or 4 pi over 4 plus pi over 4 makes this 5 pi over 4. And then if we add pi over 3 to 3 pi over 3, we get 4 pi over 3. And then let's look at what 2 pi is equal to. Well, 2 pi is the same as 12 pi over 6, 8 pi over 4, and 6 pi over 3. So if I want to find this angle right here, that would be 12 pi over 6 minus pi over 6, or 11 pi over 6. This angle is going to be 8 pi over 4 minus pi over 4, or 7 pi over 4. And then finally, this angle is going to be 6 pi over 3 minus pi over 3, which is 5 pi over 3. Now that we've finished putting in our angles, we need to put in our coordinates. But before we can do that, we have to think about what is positive and what is negative in every quadrant. In quadrant 1, everything is positive: sine, cosine, and tangent. But in quadrant 2, because the x values are negative, that means that cosine has to be negative. The y values are positive, which means sine is positive. But if tangent is sine divided by cosine, a positive divided by a negative means that the tangent will also be negative. In quadrant 3, the x and the y are both negative, which means sine and cosine are negative. But since tangent is the ratio of sine and cosine, when you divide two negative numbers, we actually get a positive value for tangent in quadrant 3. And then finally in quadrant 4, the x-coordinates are positive, so that means that cosine is positive. The y values are negative, which means sine is negative, and then that means that tangent also has to be negative. So let's label our coordinates for our remaining quadrantal angles. Over here, the coordinate has to be -1, 0. Down here, we're going 0 in the x and -1 in the y direction. Now, the thing about reference angles, the reason we even talk about them, is that they share the same characteristics. If you look here at this angle versus this angle, they both have the same height or y value. So I'm going to put 1/2 in for the sine. But notice how they both share the same length on the x-coordinate. So I'm going to write the square root of 3/2 here. But I'm in quadrant 2. I'm actually going in the -√3/2 direction, so I have to put a negative. So I'm going to use this symmetry, and I'm just going to put negatives in front of the x-coordinates of the matching values from quadrant 1. So this will have to be -1/2 positive square root of 3/2. Now, using reference angles again in quadrant 3, I'm going to use the same coordinates as in quadrant 1, except now that everything is going to be negative. So this is going to be -√3/2 and -1/2. This will be -√2/2 and -√2/2, and this is -1/2, -√3/2. And then finally in quadrant 4, we're going to use the same symmetry, and now we're going to make all of the y values negative. So this will be positive square root of 3/2 and -1/2, positive √2/2, negative √2/2, and then finally positive 1/2, negative square root of 3/2. So now we're going to do some practice problems with the unit circle. Example 1, if sine of theta is negative and cosine of theta is negative, name the quadrant in which theta lies. Well, let's think about this. Sine is the y values, and y values are negative in these two quadrants. If cosine is negative, cosine is the x values, and x is negative in quadrant 2 and quadrant 3. The overlap is in quadrant 3, so theta is in quadrant 3. Example 2, for the following exercises, state the reference angle. A, 55 degrees. Well, 55 degrees is acute, which means it already is a reference angle. So the reference angle for 55 degrees is 55 degrees. Part B, 7 pi over 5. Now it's hard to say which quadrant this is in. This is not on our unit circle, or it's not one of the special angles on our unit circle. But let's just think about where is this in relation to halfway around. Pi is always something easy to think about because a common denominator with 7 pi over 5 would mean that pi would be 5 pi over 5. We know that 7 pi over 4 is more than that. So that means that 7 pi over 5 is down here in quadrant 3, and the difference between 7 pi over 5 and 5 pi over 5 is 2 pi over 5. So the reference angle is going to be equal to 2 pi over 5. Example 3. Given that sine of theta equals 1/3 and cosine of theta is negative, find the exact value of the cosine of theta. So to do something like this, we don't know an angle on our unit circle that has a sine that's equal to 1/3. So we're going to handle this a little bit differently. The first thing we want to do is decide which quadrant does theta lie in. So we know that sine is a positive 1/3. So sine is positive in these two quadrants. And they say that cosine is negative. Well, cosine is negative in these two quadrants. The overlap is quadrant 2. So theta is in quadrant 2. The next thing we want to do is draw a sketch of the triangle in quadrant 2. So I'm going to draw a triangle in quadrant 2. I am going to give it a sign that is equal to 1/3, opposite over hypotenuse. I'm going to use Pythagorean theorem to calculate the missing side. So we know that basically x squared plus 1 squared is equal to 3 squared, which means x squared is equal to 9 minus 1, or 8, which means x is the square root of 8, or 2 root 2. Keep in mind, though, that we are on the negative side, so this has to be negative 2 root 2. So the exact value of the cosine of theta is going to be negative 2 root 2 over 3. That's all for now. Thanks for watching.